Hey guys, so today what we're going to be doing is starting day one of Acing the Algebra EOC. We're going to be covering several topics during this session. Now, make sure that you keep up with these pages because you will have a Canvas quiz. You also have a weekly assignment that goes along with these topics. So please make sure that you're keeping up with them. Make sure you have Desmos open up on your laptop, and let's go ahead and get started. So the first thing we're going to look at is simplifying radicals. And most of the time when we see simplifying radicals, it'll ask us which of the expressions is equivalent to the square root of 392 for this specific problem. The key word here is equivalent, and whenever we see this, what we're going to do is go straight to Desmos. So again, we're going to Desmos to see if we can find the equivalent expression. And what I'm going to do is I'm going to type this in. So let me get out Desmos. And if we notice in the bottom, let me move this. In the bottom corner right here, we have the keyboard. So I'm going to click it. And my square root button is that fancy looking check mark. So I'm going to click it and type in my number. So 392. And we get 19 point blah, 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 blah. Really ugly decimal. So what I'm going to do is try to find the equivalent or the one that matches. So we start with 7, square root 2, not it. It's too small. 9 point whatever. Next one we have is 14 square root of 2. And this one matches, but again, I'm going to check and make double sure that that is the only one that matches. The next one we have is 4 square root of 98. Too big. And then 4 square root of 8. And still too small. So the answer for this problem was 14 square root of 2. Again, just to show you again, we type in that first number, square root 2, and the decimals match. So the next section that we're going to talk about is evaluating functions. And when we evaluate, the key thing that we have to remember here is that we are going to plug it in. Plug in the number. So the first function that we're given is f of x equals 3x plus 5. And there's two ways that we can do this. The easiest way is just replace the x with the number given. So here, whatever number is in parentheses is what I'm replacing it with. So we have 3 times 1/3 plus 5. And I'm going to type this in Desmos, because when I type it in Desmos, it'll just calculate the number or the answer for me. And this can be given in multiple ways on the STAAR. It could be a multiple choice, or it could be a griddable where you're having to type in the answer. So for this problem, we get 6. So the answer for this problem would be positive 6. And we can do the same thing for the rest of these problems. So you need to remember to make sure that whenever you're plugging in a number, use parentheses. If not, it could calculate the answer incorrectly. So I have 2 parentheses, negative 5, close parentheses, squared plus 1. And we get 51. The next one we have is 2 times 0.75, or 3/4. So 2 parentheses 0.75, you get 1.5. Now, if your answer was in fraction form, you would click this button over here on the left. It's a little circle with the squares. Click it, and we get 3/2. and that is going to be the same answer as 1.5. The last one we have is 7 minus 3 times 4. So I type that in, and we get -5. So that is how I can use Desmos to calculate or evaluate functions. The next thing we're going to talk about is correlation versus causation and trend lines. And we talked about this back in the fall semester. It's similar as if we were going to calculate slope. And, we're looking at the R value instead of M and B. So the closer that R is to -1 or +1, the stronger this linear association is going to be. And if you look below at the chart that talks about strength, it's going to be at the far left or the far right. And these lines look like lines. They follow a pattern. So the closer they are to 1 or -1, the stronger that line is going to be. Now, the closer that R is to 0, the weaker this linear association is going to be. And that's going to be towards the middle, where there really is no pattern. It's just a bunch of dots randomly placed all over the graph. Next thing I want to discuss is the direction, and this is the most basic and straightforward. If it goes uphill, it's positive. Downhill is negative. If there is no pattern or there is no line, then there is no correlation. So let's go ahead and look at the example we have down below. So what you're going to want to do is add a table in Desmos. So I'm going to add a table in Desmos with all of those numbers in it. So give me just a second to type those numbers in. So once you get all your numbers typed in, it should look something like this. You need to go through, double check, make sure you typed in all of those numbers correctly, because if there is one typo, it could kind of skew the data a little bit, and the numbers you get in the next part might be a little wrong. So what we're going to do is type in this equation up here at the top. The y1 squiggle, the y1 squiggle mx1 plus b. So I have y1 tilde mx1 plus b. And if you forgot where the tilde is at, you press the ABC button, and it is down here below B and N. So we get a bunch of numbers here, but I'm only concerned right now about the correlation coefficient, which is R. And I'm going to be rounding to the nearest hundredth, so the second decimal place. So R equals -0.99. And this tells me that we have a strong negative correlation. And the last thing, or in part A, it asks us to determine the equation for the line of best fit. And we're going to be using the slope and y-intercept for this. So again, round to the hundredth. And my equation is going to be y equals -21.47x plus 2021.25. And this is the equation that we're going to use in part D, because it's wanting us to predict the average price of insurance for a 58-year-old. And if you look at the table, 58 is somewhere between 50 and 60. So our answer choice should be somewhere between 850 and 750. All right, so let's go ahead and type in this equation that we wrote down. We have y equals -21.47x plus 2021.25. I'm not really concerned about the graph at this point. I want to focus more on how I can transform this into a table, because this is going to be the quickest way for us to evaluate this function at 58. So I'm going to edit, turn it into a table, and type in 58. And here we can see that the price of car insurance at 58 years old is at $775.99. And again, that's another way that we can evaluate functions as well. So here is the rest of that. Moving on, we're going to talk about Hoy-Vux and perpendicular and parallel lines. So Hoy-Vux is an acronym that we can use to help us identify special cases. Hoy represents our horizontal lines, and those have a 0 slope, where the equation is going to be y equals a number. So essentially, whatever y value the line goes through. Vux represents our vertical line with an undefined slope, where the equation is x equals a number. So let's go ahead and look at the examples for these kinds of lines. So the first one we're looking at is write the equation of a line that contains a point -6, 4, and has an undefined slope. So the easiest way to do this is draw a picture. So I'm going to draw my makeshift graph of x and y axis, and I'm going to plot a point where -6, 4 should be. So about right here, ish. Doesn't have to be perfect. We're just looking at the picture. So it's telling me that it has an undefined slope, so vertical line. And we're looking to see which x value this line goes through. And if we recall, on our point, -6, 4, the x value this line is going through is at -6. So that is how we can write the equation of this line. Looking at the one below this, we're going to do the same thing, except we have a 0 slope. So still at -6, 4, and a 0 slope. Again, we're looking at -6, 4. The y value in this point is at 4, so my equation is y equals 4. Next problem, we need to identify the slope for each of the following equations. Then identify what type of line it is. Is it going to be horizontal, vertical, whatever? So, using our handy dandy chart on the left side of the paper, if y equals a number, this is going to be a horizontal line. So we have horizontal line and 0 slope. X equals a number, we have a vertical line and undefined slope. Same thing with C. I have a vertical line and undefined slope. For Y, we have a horizontal line and a 0 slope. So here, if you can remember Hoy-Vux, then anything with these types of equations will be a breeze. Next question, we need to write the equation of a line that passes through the point 6, -6, and has a 0 slope. So, when in doubt, draw a graph. We're at 6, -6, 0 slope. Looking at this point, my y value, because I'm going through the y-axis, is at -6. So y equals -6. Same thing with the next one, or similar situation. We have a point at 212, so pretend that this is all the way up at 212. And it has an undefined slope. Vertical line at 212. My x value is 2. And that is Hooy-Vuk's parallel and perpendicular lines. In the next section and last section for this day, we're going to talk about transformations of a linear and quadratic function. So the first one we're going to look at is a linear function, and the best way to work through these kinds of problems is to graph them in Desmos. For the sake of this, though, since there are no examples really, I'm just going to be writing them down. So for the linear function, we have if a is greater than 1, a is less than 1. So if a is greater than 1, so again, if a is greater than 1, we can consider this to be a vertical stretch, and it makes the graph steeper. So again, we have a vertical stretch. And it makes the graph steeper. So if a is less than 1, meaning it's a decimal, fraction, whatever, then this is going to be a vertical compression. And it makes the graph flatter. So that is what happens to our slope if a is bigger than 1 or less than 1. The next thing I want to talk about is the horizontal movement. So again, this affects our x values. So it affects our x-intercepts. And this is all technically kind of backwards. So if I have x plus c, so x plus c, let's look and see how that affects our graph. So let's say I had y equals x plus 2. And it moved my graph to the left 2 units. So because this number is positive, it moves our graph to the left. Which means that if we have a negative, it's going to move our graph to the right. So this is considered to be a horizontal shift. B, or the number at the end, affects our y values. So this is considered to be a vertical shift. This one is very straightforward because if B is positive, we go up. If B is negative, we go down. Now, if we have a negative number out front, so if we have a negative sign, out front, this will always be a reflection. We're going to reflect across the x-axis. And let me show you what that looks like right quick. So let's say I have a negative number out front, and we'll compare this to x. So if I have y equals negative x, it essentially flips and goes the opposite direction. So that's what we mean by a reflection. The last thing I want to talk about, which is something we recently covered, is quadratic function transformation. So again, a quadratic function is going to be x squared, and this is the one that produces the parabola or the U-shaped graph. So if a is bigger than 1, still going to be a vertical stretch, except our graph is going to get skinnier. If a is smaller than 1, it's still a vertical compression. And our graph gets wider. The number in the middle is still going to be that horizontal shift, and it still works the same way as what we talked about above. If it's positive, we go left, negative, we go right, and again, this affects our x values. Same thing for the last number. So this is again a vertical shift. Positive goes up, negative goes down, and this affects our y values or our y-intercepts. And lastly, same thing, a negative number or negative sign out front will always be a reflection. And if you want to play around with any of these or need to ask questions, go to Desmos, ask your teacher, ask a friend. Look at your notes. Use the resources we have given you to complete the assignments and activities that are assigned for after this lesson or video. If you have any questions, just let us know and have a good day.